Hi, for experiment number 1, we need to use the antacid table and we need to put it here and broken it into small pieces. Just like this. For the second experiment, we need to drop the pieces of the antacid table in a cup and then drop 1/2 of cup of water. And this is what happens. For the third experiment, we need to use an ice cube and leave it in a cup for 15 minutes. For the fourth experiment, we need to use 1/3 cup of lemon juice and 1 teaspoon of baking soda. And well, this is the reaction.
For experiment number 5, we are going to model some Play-Doh. As we know, Play-Doh is a solid item, but it is also really soft and malleable. And let's observe if we have any change. So, okay, so the plastilene or Play-Doh gets even softer when it's in smaller pieces and amounts, but it does not change. It stayed the same way as it was in the same beginning in a chemical way. We change it physically but not chemically. And here we can observe just physical changes because matter did not change at all, just the size, but it's part of the properties of matter. So here we just can observe physical changes. In experiment number 6, we are going to observe the reaction that is going to happen between vinegar and baking soda. So, in our glass, we're going to add 1 teaspoon of baking soda. And we are going to add a 1/4 cup of white vinegar. Okay, as we can see, we have an effervescent solution, and we are looking how bubbles go upwards. There is still some baking soda in the bottom of the glass, but it was almost dissolved. And In our experiment number 7, the mixture of vinegar and milk, we can observe a chemical change, and we can say this that because we have a new substance from the first two that we have. Now that we have our vinegar and our milk combined, we can see that vinegar cut milk, and this gave us a new substance, and we can observe a chemical change. In experiment number 8, which was the mixture of Kool-Aid powder and water, we can say that we are having another chemical mixture because from our two principal elements that were the Kool-Aid powder and water, we transform it to another substance that is flavored water. So even though we are combining two states of matter, we are having a chemical change because we are transforming them to another substance.
Now I'm going to do the sugar experiment in the pan. We have the pan here, so I'm going to throw the sugar. As we can see, it's melting. It's becoming brown. Okay, so we can see it's melting and becoming brown here. It's smelling like candy. It has a strong flavor. We can see it's already becoming liquid. It's dense, it's a dense mass, and it's now brown, fully brown. Yeah, it's like honey. So yeah, this is a chemical reaction, the sugar against the fire. Thank you. Now I'm going to do the first part of the acetone experiment. For this experiment, we're going to use the acetone and a cup. So we are going to throw the acetone into a cup and see how it reacts. It smells Hello, today is the day number 2 of the acetone experiment, and we are going to see the changes. First, we can see it decreases a lot from its original liquid quantity. Next, we can see the color. It is a lighter green than before. It also smells more stinky. We can see this is a physical property because of the evaporation. I'm going to proceed to making the experiment that consists of breaking a piece of paper in small pieces. So I'm going to proceed. Okay, we can see nothing changes in the structure, but now we have more papers, but small ones. But the chemical structure is the same. That's why this is a physical change. Hello. For this experiment, I'm going to burn this paper. This. Okay, so we are going to see the reaction. So I'm going to turn this. So you can see okay, so we can see the paper burned completely. This is a chemical reaction because this chemical structure changed. We can see it black, we can see dark, and the structure is soft. Yeah. Thank you.